Across the board, attackers continue to develop new ways to evade defenses and compromise enterprise systems. We've seen this relative to applications as well, with the speed and decentralization of both development and deployment opening up new avenues for attack. I'm pleased to be joined by one of the founders and CTO of ThreatX, Andrew Useckas. Andrew, thanks for being here.
Thank you.
So ThreatX is not the only vendor moving towards or offering web application and API protection, or WAAP as the market has started to call it. So could you tell me a little bit about the ThreatX architecture and how the approach is different from first generation solutions?
Yeah, absolutely. So we're cloud centric first. And our containers are Dockerized. So basically our sensors are containers that can be deployed anywhere. We can deploy in any cloud, we can deploy on premise, it doesn't really matter. So ease of deployment is also pretty big as far as our sensors are concerned. In addition to that, we deploy a centralized analytics engine, which we call HackerMind, which allows us to take inputs from all of these sensors, doesn't matter where they're running, and we can make centralized decisions for all of these sites hosted by a customer, as well as we can do cross-customer correlation using that analytics engine.
Could you walk us through a typical customer deployment? So in other words, how long does it take to get the solution in place? One of the historical issues with WAF has been the tuning time frame. So what's involved from that perspective? Really, what's required from the security team to get things up and running?
As far as the deployment goes, it's pretty easy to deploy us. If you decide to use, for example, our cloud, all we need to do is deploy sensors for you, which take up to 5 minutes sometimes. I mean, it's a very short time. And then the onboarding of the application itself is basically just a DNS switch. So all you need to do is basically go into your DNS provider and switch the pointer from your original backend to us. And then basically the data starts flowing and we start profiling data. And usually we can go into blocking mode within 24 hours.
One of the things you mentioned was the HackerMind engine. And what I find fascinating about this approach is that it looks at things not just as individual events, but it really correlates everything back to an entity and then provides a view of not attacks just on a single application, but kind of across the environment. So can you just walk us through a little bit more about how that detection engine fits into the approach?
Yeah, absolutely. So the centralized analytics engine, called otherwise known as HackerMind, basically allows us to take all the inputs from different sensors. So if sensor detects any anomalous behavior, any malicious behavior, it basically forwards the metadata back to the central analytics engine. So the centralized analytics engine can then take all of these inputs from all of these sensors and correlate them and make decisions, risk decisions, so targeting decisions or whatever else need to be on the global scale. So basically, if we decide to block somebody, that block will be pushed to all of the sensors. We use fuzzy logic engine, which allows us to assign risk based from 0 to 100 to all the actions of a specific attacker. And that specific risk-based approach allows us to track events that other binary solutions might not consider to be serious enough to even bother with. But that basically allows us to see what the attacker is doing from the very beginning and track them as they're going through different attack steps. And we track that attacker for up to 90 days. And that basically allows us to reduce false positives. Because we track all of these little things, we can see exactly what they're doing. We can see what stages they're going through, and then we can make a decision that if they accumulate enough risk, they're going to get blocked.
One of the important things to consider with bot mitigation is there's a number of different types of bots. Some are malicious, some are just more of a nuisance. There's a broad spectrum in between. The defenses for bot mitigation have been owned by different parts of the organization at different times. So how does ThreatX really defend against all these different types of bots as part of the platform?
We deploy different detection methodologies in order to detect bots. Obviously, as you mentioned, there are good bots out there. So for example, we don't want to block Google search engine. Or Bing or any other major search engines. Those are whitelisted by default. But other than that, we implement different steps to detect actual bots. And that begins with your basic intensity checking. So how fast is this specific attacker sending requests? Are we talking about a few requests a minute, or are we talking about thousands of requests a second in that case? So that's the initial thing that goes into determining if it's automated or if it is an actual person doing something on the other side. In addition to that, we deploy interrogation techniques as well. So we will inject cookies, we'll inject JavaScript, we will determine exactly what the other client is. So we will look at what CPU they use, what resolution they use, what fonts they have installed, and combining all of that data into a single, basically, hash value. In addition to that, we also look at TLS fingerprints. So with fingerprint client to determine exactly what they're trying to do and what they are. As part of the learning, as part of, when you onboard the application, when we go through the baselining process, that, first 24 hours, if we notice that you're being hit by a lot of bots, we usually go back to the customer and ask, do they want to allow this or not? And some customers choose to allow them. Some customers want to block pretty much everything but the main search engines.
Makes sense. There's a really interesting approach, Andrew. Thanks so much for taking the time to discuss ThreatX's approach to application security.